Milling of wheat. Wheat is generally not consumed as a whole wheat or a whole cereal because it is very hard and tough, and it is also difficult for digestion. Wheat is usually milled into the flour. The powder that we get from wheat after it is ground is called as the flour. Most of the wheat that is consumed worldwide is in the form of flour and the products that are prepared from the flour. Therefore, milling of wheat is very important. We will be seeing about the various steps that are involved in the milling of wheat in this segment. Wheat is consumed in the form of flour obtained by milling the grain. The flour that is obtained from milling the grain is called as the wheat flour. Indian wheats are hard. There are three different types of wheat I told you. They are the soft wheat, hard wheat, and the durum wheat. And the wheat that is largely cultivated and obtained in India is the hard wheat. And the moisture content of the hard wheat is very less. It is about 8 to 10%. The traditional procedure for milling wheat in India has been the stone grinding. Traditionally, in the conventional method, the stone grinding was used, which we call as the grinding of wheat using, in Tamil we call it as Yendram. There are two stones that are there, and in the upper part of the stone there is a small portion which is hollow where the grains can be added, and by rotating the upper portion of the stone, the lower portion is fixed and the upper portion is movable. By rotating the upper portion of the stone, the wheat was ground conventionally. But now we are using mills which are called as the modern mills. In the modern milling, the wheat is subjected to cleaning to remove various types of impurities together with the damaged kernels. So the first process in the milling of any grains including wheat is to remove the impurities that are present. When the grains come from the field, it is contaminated or there are different types of impurities that are present in them. So the first step involves the removal of impurities in the cereals, and in wheat milling also in the first step we remove the impurities. Vibrating screens. In the milling process, the wheat first passes through the vibrating screens. The vibrating screens removes bits of straw or the coarse materials that are present along with the wheat, and it also removes other seeds, other foreign material. It may be contaminated with other cereals like barley or rye or anything bajra. So the other foreign materials, other grains are removed. So the first step is it removes the bits of straw. Straw is nothing but the plant that is dried. The wheat plant which is dried is called as the straw. So the wheat grain, when it is sent to the mill, may be contaminated with the straw particles, the dust particles, and this is removed. The next step is when there are other grains other than the wheat grains, they are also removed, and this is done by passing the wheat through the vibrating screens. After it goes through the vibrating screens, after the impurities are removed, it next passes on to the aspirator. In the aspirator, the lighter impurities that are present along with the wheat grains are removed. What are the lighter impurities? Whichever particle has a lighter weight than the wheat, they are the lighter impurities. The lighter impurities can be straw particles, bits of dry leaves, or it can be the dust particles that come along with the wheat. So these are removed in the aspirator. The stream of wheat, a steady flow of wheat, is directed across the screens, while the air sucks off the dust and the lighter particles. So we drop the wheat steadily through an input. There is a fan present inside the aspirator. This fan is responsible for generating air flow. When air passes through the wheat, what happens? The lighter particles will fly. The lighter particles will come up, they will fly, and these lighter particles are sucked off from the wheat. And what we get now will be the wheat which does not have any type of impurities. So in the aspirator, air is blown through the wheat. During this process, the lighter impurities will come up, they will fly, and this is sucked away, and therefore it is free. The wheat is free of any dust particles. In this image, you can see the vibrating screen. The vibrating screen is responsible for removing the impurities that are present in the wheat. This is the aspirator, which is responsible for removing the lighter impurities, the dust particles that are present along with the wheat. In this image, you can see here the product inlet. It is here the wheat comes inside the machine. So through this, a steady stream of wheat will flow. It comes here, and here there is a rotating fan. The fan is responsible for producing air. So when the wheat comes here and the wind blows in this portion, what happens? The lighter impurities, they are removed. They will fly up and they are removed here. The lighter impurities will go into this chamber, and from this chamber the lighter impurities are removed. And here the product outlet. Here is the product outlet. In this product outlet, we will get the wheat which is free of any type of impurities. After the impurities are removed, wheat passes to the next step. It goes into the disc separator. The disc separator consists of several discs revolving in a horizontal axis or a vertical axis. It depends upon the design of the machine. The surface of the disc is indented. What is indentation? Indentation means there are certain small portions that are hollow in nature. So that is called as the indentation. In this indentation, only one wheat grain can fix itself. So in this indentation, they catch the individual grains of wheat and they reject larger or the smaller ones. So there are depressions in the discs. There are small depression, and in this depression only it is in the size of the wheat grain. We know the approximate size of the wheat grain, and so this depression will be only in the size of the wheat grain, and only one wheat grain can be held in the indentation. So if there are other grains along with the wheat, if they are larger or smaller, those grains will be rejected. So this is the purpose of the disc separator. In the disc separator, wheat grains are separated from the other grains that are mixed with the wheat when they come from the farm. Next, it goes into a machine called as the scorer. Scorer is a machine in which beaters are present. Beaters are fixed or attached to a central shaft. So this is something like a mixie jar. In the mixie jar, we have a central shaft. There we fix the blades. So here also it is something like that. Just for your imagination, I am telling you. So there is a central shaft which will throw the wheat violently against the surrounding drum. So in the mixie jar, we have a central shaft where the blade is fixed and there is a jar. So when we switch on the mixie, what happens? The blades rotate, and whatever you add into the jar, they are thrown on the mixie jar. Here also, the wheat is violently thrown against the surrounding drum. So there is a shaft. When you switch on, the shaft will rotate, because of which the wheat will be thrown on the surrounding drum. So when it is thrown with force, violently, means with a very strong force, when it is thrown on the surrounding drum, the kernel will break, right? It will buff the kernel and the kernel will break, and the hairs that are present in the kernel, when we saw the structure of the wheat, I told you there are hair-like structures present in one of the edge of the wheat. So the hair-like structures are removed, and also the wheat kernel. What is wheat kernel? The grain of the wheat is called as the wheat kernel. They are broken. In this image, you can see the disc separator, and here you can see the series of discs that are present. In this disc, there are indentation, and this indentation only one wheat grain can get itself fixed, and those grains that are larger or smaller will be rejected. This is the scorer machine. There is a central shaft, and when the central shaft rotates, what happens? The wheat grains, they violently hit the drum and they are broken. This is the scoring machine. Next, the wheat passes into the magnetic separator. The stream of wheat next passes over a magnetic separator that pulls out the iron or the steel particles contaminated during harvesting. So during harvesting, different types of equipments are used for harvesting the wheat grains from the field, and there is a possibility of the wheat get contaminated with the iron particles or the metal pieces that are used for the harvesting purpose. So these metal pieces must be removed from the wheat grains because it can cause dangerous problems if it is consumed. Therefore, for separating the iron and the steel particles, the wheat has to be passed over a machine called as the magnetic separator. As the name indicates, there are magnets present in this machine, and when the iron particles passes through this machine, the iron particles will get attracted towards the magnet and they will stick to the magnet. And after the wheat passes through the magnetic separator, we can assure that the wheat does not contain any metal contaminants in them. The magnet will remove all the iron or the steel particles that are present in the wheat grains. After it passes through the magnetic separator, next the wheat enters a machine called as the washer stoner. The washer stoner has high-speed rotators that will spin the wheat in a water bath. So this actually is a water bath. Water bath is a container that contains water, and there are high-speed rotators. These high-speed rotators will spin or it will revolve the wheat in the water. Excess water is thrown out by centrifugal force. Because it is a rotator, the wheat and the bin is now rotating, revolving, right? So during this, the centrifugal force will remove any excess water that is present in the bath. Stones drop to the bottom and they are removed. So what is the purpose of this machine? This machine will help in the removal of stones that are present along with the wheat grains. And because water is present, when the wheat enters the water bath, those that are lighter than the wheat will float on the surface. So those impurities, those that float on the surface are impure and they are not sound kernels and they can be removed. At the same time, the stones that are present will go to the bottom because it is rotating. The washer stoner is rotating, and therefore because of the centrifugal force, what happens? The heavier particle go to the bottom and the lighter particle comes to the top, and all the stones that are present will go to the bottom. So this method we also employ in our homes for removing the stones from the rice. If you have observed your mother using a vessel, a utensil in which water is taken, rice is added to that, and by spinning the utensil and removing the rice from the upper portion, at the bottom there will be stones and that will be discarded. So the same mechanism is employed here to remove the stones and also the lighter impurities. So this is done in an equipment called as the washer stoner. Wheat is taken, water is added, and the water bath rotates. During this process, the heavier particles go to the bottom, the lighter particles come to the top. Both the heavier particle as well as the lighter particles are removed. Okay, so the stones can be removed in this process. So this is the magnetic separator where the metal particles, particularly the iron and the steel particles, can be removed. You can see here how the magnetic roller is there and it removes the metal particles separately and the wheat separately. This is the washer stoner that is used to remove the lighter impurities, the unsound kernels and also the stones from the wheat. The next step in the milling of wheat is a very important process called as tempering. Tempering is the process in which moisture is added to the wheat before it is ground. Before the wheat is ground in the machine, moisture is added. Why should moisture be added? Moisture is added in order to separate the bran from the endosperm. So in the outer portion of the wheat grain, there is the husk, the pericarp and the bran. So this bran should be removed from the endosperm. The percentage of moisture, the length of soaking, the time for soaking and the temperature are the three important factors in tempering. So how much of moisture should be added to the wheat depends upon the type of the wheat grain. And this will also determine the length of soaking. Length of soaking is the duration of soaking the wheat grain, whether it should take half an hour or 1 hour or 2 hours is the length of soaking. And also the temperature at which it should be soaked. These are the three important factors involved in the process of tempering the wheat. The dampened wheat. What is the dampened wheat? We have now added moisture to the wheat. Why has the moisture been added? What is moisture? Water is added. So the water has been added in order to facilitate the removal of the outer portion, that is the bran of the wheat from the endosperm. The dampened wheat, that is the wheat along with the water that has been added, is held in the bin for 8 to 24 hours. So we make the wheat moisture and we keep them in a bin and cover it for about 8 to 24 hours. Now, during this process, the outer layers of the wheat will become brittle. Brittle means it can be easily removed. It is easily broken. And the tempering will toughen the bran coat to permit more complete separation of the endosperm. So what will happen? Water is absorbed by the wheat grain and also the bran. The bran will become tough because water has been added and it can facilitate easy removal. Tempering will also condition the endosperm so that the floury particles break more freely during the milling process. So tempering has two advantages. One advantage is the outer husk or the bran portion of the wheat can be easily removed because the bran becomes tough when it absorbs the moisture. And the next advantage is the endosperm will also absorb the moisture and so it is conditioned and the flour that is obtained from the endosperm is very soft in nature. It will break more freely during the milling process. So this image shows the tempering bins where the wheat is kept or held for about 8 to 24 hours. This shows the cross section of the tempering bins. Next, the wheat passes to the entolator, a machine called as an entolator. In the entolator, there are discs that are revolving at high speed in the scorer aspirator, which hurl the wheat against the finger-like pins. Here also there are discs the discs are revolving at very high speed, and during the rotation of the discs at high speed, the wheat is thrown against finger-like pins. And when the wheat is thrown against the finger-like pins, in the impact, that is in the pressure, it will crack and the unsound kernels will be rejected. So here, if there are certain kernels which are not good, which has lighter weight, they can be removed. So in the enterlator, the wheat is broken. Next, it passes to the grinding bin. The first break rolls. There are rollers present here in the grinding bin, and they are called as the first break rolls because it is here the actual conversion of the wheat to the flour takes place. So the first break rolls, they are corrugated and they are not smooth. Corrugated means there are certain corrugations or indentation that are presented in the discs, and they will break the wheat into coarse particles. After the wheat has passed through the enterlator, where the unsound kernels are removed, it first goes into the grinding bin. In the grinding bin, the first break rolls are present. Why are we calling it first break rolls? Because there are several breaking rolls like this. So here the first break rolls are present. So they will break the wheat into finer particles. This is the enterlator that is used to remove the unsound kernels from the wheat grains. And these are the finger-like pins that are present in the enterlator. And these are the grinding bins where the first break rolls are present. The first break rolls are used to break the wheat grains. Next, the wheat passes through a sifter. So what is sifter? Sifter is something like a jalladai. The broken particles of wheat and the bran go into a box like sifter where they are shaken through a series of screens. Like we use jalladai, here there are different screens. Series means many number of screens are present which will separate the larger particles from the smaller particles. When we use a jalladai to sieve the flour, what happens? The larger particles will be present in the jalladai and the smaller particles will flow through the jalladai. And the same principle is used here also. There are a series of screens which are present in the sifter which can remove the larger particles from the smaller ones. After it passes through the sifter, the wheat flour enters the purifier. The top fractions and particles of the endosperm are carried to the purifier. In a purifier, there is a controlled flow of air. So in the purifier, there is a steady stream of air that is blown through, which will lift off the bran particles. It will remove the bran particles because bran particles is not required here. The bran particles are removed while the screens will separate and grade the coarse fractions size by size. So I told you they are like jalladai, the sifters. Here the pores that are present in the screens will be of different dimensions. So the coarser portion will be removed in one segment, and next finer will go to the next segment, and the most finest will go to the next segment, and thereby they are separated in fractions based upon the size and quality. So these are the sifters. Here there are a series of screens that are present with different pore size, and they can remove the particles in different sizes. Next, the wheat goes into the down purifier. So we saw the first break roll. Next, they pass through 4 or 5 additional rolls, which means there will be a second break roll, third break roll, fourth break roll, and fifth break roll. So they go through 4 or 5 additional rolls successively through final corrugations, and each followed by a sifter. And they are used to rework the coarse stock from the sifter and reduce the wheat particles as free from bran as possible. So they will go through the second break roll, sifted, third break roll, sifted, fourth break roll, sifted. So it goes on through these processes where the flour and the bran will be removed, and the fine particles, the particle size will become finer as they go through the third and the fourth break rolls. The germ particles are somewhat plastic in nature, and therefore they will be flattened by passage through the smooth reduction roll, and they can be separated easily. So now the endosperm, the bran has been completely removed. By aspiration, the bran particles, they are removed, and then they pass through the second break roll, sifter, third break roll, sifter, fourth break roll, sifter, fifth break roll, sifter. So during this process, what happens? The wheat grains, they are ground, and the particle size will reduce as desired, and we will get at the end the most fine powder like particles. You can see here the break rolls. The cleaned wheat, they pass through the break rolls, then they are sieved. Again, they pass through the break rolls, they are sieved. And while sieving, you will get the germ, the white feed. White feed is nothing but the flour, which again will be milled, and then the bran. You can see here the bran is also present. The white feed, again it will go through the reducing rolls, and you will get the white flour. So at the end, you will get the white flour. This is what we should get at the end of milling wheat. And the other products that you can get during the milling process are the germ, the feed, and the bran. The process is repeated over and over again by passing the wheat through the sifters, purifiers, and the reducing rolls until the maximum amount of flour is separated, which consists of at least 72% of the wheat. So 72% of the wheat is ground into a fine flour, and the rest will be the bran and the germ and the impurities that are removed from the wheat. This image shows the entire process of flour milling, the preparatory process and the equipments that are required for the preparatory process, the cleaning process, the wheat cleaning process are the equipments that are required for the cleaning process. And then next here it shows the flour milling. What are all the equipments that are needed for the milling of wheat? And after the flour is milled, then you can fortify or enrich the flour and you can pack it. So these are the various equipments that are required for milling of wheat. And this figure shows the process involved in the milling of wheat. This is a large figure, and I have split this figure into various portions. So you can see here the wheat grain, it comes in trucks to the factory, and here the quality of the product is analyzed. The magnetic separator is used to remove the metal particles, and then it goes through a separator where the impurities are removed. It goes through the aspirator where the light particles are removed, and then I told you stoner where the stones are removed. Here the disc separator, in the disc separator, the other grains like the barley, oats, etc. are removed. It goes to the scorer. Next it goes to the scorer. In the scorer, we have the beaters which will score off the impurities. Next it goes to the tempering bins where water is added and it is kept in the bin. Next it goes to the grinding bin where the rolls are present. So here this is the first break roll. After it goes through the first break roll, wheat is broken and it is sifted. So sifting will enable the removing of the larger particles from the finer particles. Then again it goes to the purifier. Next is the second reducing roll. It goes to the sifter. Again, there are series of purifiers and reducing rolls. Then it goes to the entellator. And here you can see that the germ rolls are there. The germ is collected. And here the flour is obtained. This flour can be enriched. Enriching means addition of vitamins or minerals, right? To enrich means to add additional nutrients. That can be done. Vitamins or minerals can be added to the flour, and this can be stored. It can be packed. After it is packed, it can be transported. And similarly, here you can see that after sifting, we get the brands, the shots, and the clear flour. So these are the various steps that are involved in the milling of wheat. As we saw the various equipments, the equipments are not present separately. They are integrated, right? One after the other, the machines are integrated. And this is the layout of the flour mill. And here you can see the wheat milling plant. So when large quantities, several tons of wheat flour has to be ground, then it goes to the wheat milling plant, and this is how the wheat milling plant will look like, where all the machines are automated and it takes place automatically in different stages, and the output will be the wheat flour. We get the wheat flour as the output from the wheat milling plant. Thank you.